This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 10 of Week 2. Compressible flow, Mach number, isentropic stagnation relations, choked converging nozzles, normal shock jumps, and a primer on Fanno adiabatic frictional flow. 4 exam patterns, 1 root idea, Mach number and the speed of sound test, isentropic stagnation relations, normal shock jumps, and Fanno adiabatic frictional flow in a constant area duct. All 4 engage when Mach exceeds about 0.3. Below that, treat the gas as incompressible. Bernoulli still works. Mach number is the flow speed over the local speed of sound. Speed of sound for an ideal gas is the square root of kRt, with temperature absolute, Kelvin or Rankine, never Celsius or Fahrenheit. Below Mach 1 subsonic, at 1 sonic, above 1 supersonic. The compressibility cutoff sits near Mach 0.3. The stagnation state is a reference. The moving gas brought to rest with no heat transfer and no entropy rise gives the stagnation values T0 and P0. In an adiabatic duct, stagnation temperature is constant everywhere. Stagnation pressure is conserved only when the flow is also isentropic. Friction kills it, shocks kill it. Both show up later. 5 keywords route you to the right subsection: Mach number or speed of sound, stagnation or total temperature, or isentropic flow at a given Mach, or the function tables, converging nozzle, throat, choked, or critical pressure ratio, normal shock with upstream and downstream Mach, an adiabatic frictional duct with the 4FL/D group. Bookmark the function tables. 3 sets of pre-tabulated columns at each Mach, isentropic ratios, normal shock ratios, and the Fanno group. The single most overlooked tables in the handbook. Don't crank the algebra by hand. Look it up. Variable table for nozzle problems. Gas properties up top, then reservoir stagnation conditions and throat area, then derived quantities, speed of sound, Mach, stagnation ratios, the critical flow constants for air sit ready. Bottom, the choke test and locked-in mass flow. Worked example, air at 200 through a duct at 25 Celsius. Convert temperature to Kelvin first, that's the trap. Speed of sound is the square root of kRt. Mach is V/A, about 0.58. Subsonic, but above the 0.3 cutoff. So isentropic relations apply. Isentropic stagnation ratios. Stagnation temperature over static is 1 plus K minus 1 over 2 times m squared. The pressure ratio is that raised to K over K minus 1. At Mach 0.6, the pressure ratio is about 0.784. Distractor watch, 0.528 is the sonic critical ratio, not the answer here. Choked converging nozzle. The critical pressure ratio for air is about 0.528. Once back pressure drops to or below that fraction of stagnation, the throat goes sonic and mass flow locks. A 200 kilopascal reservoir first chokes at 105.6, and the choked mass flow formula gives about 0.20 kilograms per second. Normal shock. Upstream supersonic, downstream subsonic. Static pressure and temperature jump up. Stagnation temperature unchanged. The shock is adiabatic, but stagnation pressure drops as entropy rises. At upstream Mach 2 for air, downstream Mach about 0.58, pressure ratio 4.5, stagnation recovery only 72%. Read it from the shock table. Memorize the shape, not the numbers. Fanno flow, steady, adiabatic, constant area, frictional flow of an ideal gas. The key takeaway: friction is a one-way ratchet driving Mach toward 1. Subsonic accelerates, supersonic decelerates, both converge on Mach 1. Stagnation temperature unchanged, stagnation pressure drops as friction generates entropy. Choking hits at L star, where Mach reaches 1. The Fanno parameter is 4FL star over D, the dimensionless distance to choke from any Mach. Table I's, look it up at the inlet Mach and at the outlet Mach. The difference equals 4F times the actual length over D, so rearrange for length. For air with F around 0.02 and a 5 cm pipe, Inlet Mach 0.3 to outlet 0.6 takes about 3 meters of duct. Recap. Mach example 0.58. Pressure ratio at Mach 0.6, 0.784. The reservoir chokes at 105.6, locking in about 0.20 kilograms per second. Shock at Mach 2, downstream near 0.58. Pressure jump 4.5, 72% stagnation recovery. Fanno, 3 meters of duct. Always Pascal absolute, Kelvin, square meters. 6 traps. 1. Gauge instead of absolute pressure in any stagnation or choked formula. 2. Celsius instead of Kelvin in the speed of sound formula, off by about a factor of 3.5. 3. Incompressible Bernoulli above the Mach 0.3 cutoff. 4. The choked formula without first checking the back pressure ratio is at or below 0.528. 5. Defaulting K to 1.4 for steam or refrigerants. The critical ratio shifts. 6. Ignoring the function tables. Take 6 things into the exam. Mach is V over A, with T in Kelvin. Stagnation ratios use the 1 plus K minus 1 over 2m squared form. Critical pressure ratio for air, 0.528. Choke check first, choked formula second. Normal shocks turn supersonic into subsonic. Stagnation temperature preserved, pressure lost. Fanno friction drives Mach toward 1. 4F L star over D is your handle. And the function tables save you minutes. Onward to topic 11, fans and fan laws.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.